Hi everyone. So let's continue where we left off. So we want to prove that we can calculate the GCD and the LCM by using prime factors. So the GCD is the highest common factor of two integers. So decompose the integers into products of distinct prime, and you get products of prime factors raised to powers. So since if you have the highest common factor, it would be some multiplication of those prime factors that appears in both. So in particular, it's really since we want it to appear in both, then it's a minimum power of both exponents. Whenever we station the primes from increasing to decreasing and having the same length in both, and raising certain primes to the zero power to get 1 where it doesn't appear in both of them, where for the primes that don't appear in both. So the book doesn't really state that explicitly, but I'm mentioning it now. So anyways, continuing this logical flow. So what we have is the following. Let's say we write A. Let's say we have, so let's say we write T to be the P1 to N1 to Pk to Nk, where the Ni is the minimum of Ri Si. And then we have, since T, so T divides both A and B, because by construction it appears in both the factors of A and the factors of B, so it must divide A and B. So then that means that by definition of the GCD, T divides the GCD between A and B, which is D. So we could factor D as products of distinct prime. So you have P1, L1, Pk to Lk. Then what we could do is the following. Is we know that D divides both A and B, so then that means that D is less than both A and B, and since it divides A as well as divide B, and we must have, so since D is less than or equal to both A and B, then we can write A as P1 L1 times Pk Lk multiplied by P1 R1 minus L1 up to Pk Rk minus Lk. Similarly for B. So the reason that I use that D is less than or equal to both A and B is that those powers are less than both powers of a and b, less than or equal to both powers of a and b. Then we can factor things like that. So you have P1, L1, PK, LK, and you have P1, S1 minus L1, PK of SK minus LK. And here, for a fixed I, we must have that Pi to Li divides both A and B, so it must appear in both of them. So in particular, Pi, Li, so in particular, we must have that Li is less than the maximum so since divides both A and divides B, so then we must have that it is the Li must be less than the minimum of the Ri and the Si. So in particular, we must have that D is less than or equal to T. So therefore, T is equal to D. So what we could do for part B, we're done with part A, is that the LCM of A and B is equal to A multiplied by B divided by the GCD of A and B. Then we have here P1 R1 plus S1 to PK of RK plus SK divided by P1 of N1 up to PK of NK. So this is equal to P1 of R1 plus S1 minus N1 up to PK of RK plus SK minus NK. So what is that? So here we get that Ni is the minimum of Si the minimum of Si Ri, or let's say Ri Si Ri Si. So then R1 plus S1 minus, so let's just use Ri plus Si minus the minimum of Ri Si. That would remove one of the minimums, which could be either Ri or Si. So then that would be giving us the maximum of Ri Si. So then, therefore, A and B is P1 maximum of Si Ri up to Pk maximum. Oh, this is S1 R1 Sk Rk, and we're done. Okay, I hope you guys enjoyed the video, and I will see you in the next one. Bye.